Hello guys, and welcome to another video. In this video we'll be solving an example problem on Norton's theorem. We are trying to broaden our scope on the topic. So we try solve multiple questions so that we try brace ourselves for further exams questions. So without further much ado, let's just dive right into this video. Kindly subscribe in case you are new here. Hit on the bell icon so that you don't miss out on any uploaded video. With that being said, let's dive right into this video. So if you've watched my previous video, you'll notice that I introduced shortcut tricks in solving Norton's theory. In case you've not watched that video, kindly go back to our playlist, watch it, and then come back to watch this one again. So we'll be implementing the exact techniques in solving this question. So you know that this is the Norton's circuit. You have a IN, RN, RL, and then you have a I, and then this is the general Norton's formula, and this is what Rn equals RTH. This is from Thevenin. We know that the resistor, the total resistance in the Thevenin resistor, or in the Thevenin theory based question is the same as that of Norton's. And then we know this. This is our power rule. This is the most important rule. You know that the R is what you remove, I is insert, K is what using Kirchhoff's, and then R is what finding the either Thevenin or Norton's resistor. And then we implemented our Ohm's law. This is Ohm's law. But this is a technique I usually use in solving Norton's theory. That makes the work a bit much easier, and straightforward. So we implement Thevenin in solving Norton's question. Now let's dive right into this video. So in case you've been given a question and then you are told to find what the current flowing through this 2 ohm resistor, that's what EF. You are told to find the current flowing through this resistor. So all you need to do is to do what you first remove. That's our first technique. You first remove. So that's what you remove and represent your resistor with any variable. So let's say it could be X, Y. So we remove this 2 ohm resistor and then represent it by what XY. And then the next step is what you insert your note. We are trying to solve using Norton's theory, but in order to make a solution much easier, we will implement what Thevenin, and then we bring in Norton to find our final answer. So stay with me and then you get to understand what we will be doing. So first you do what you remove the resistor, and then the second step is what you insert. So we are coming to insert our VTH. So now we have 7 volts over here, and then we have a certain 2 ohm 3 ohm over here, right, and then we have 5 ohm. So in our previous video we did that for finding the current in 5 ohm resistor, so you can just check that one out. And then we have so this is where we are inserting our VTH. So we just insert our VTH over here. Right, so all you have to do is just insert your VTH. So this is our VTH. Let's put the current in this direction. And then we move on to 2 ohm. Right, so we have another resistor over here. So we have our 2 ohm resistor over here. So we have 2 ohm. We have another 2 ohm over here. We have 5 ohm. We have 3 ohm and 2 ohm. Right, so now we have another 10 volts over here. So let's bring that in. We have our 10 volts. Right, so now we are done with insert. So you've inserted the VTH. Now what's next? What's next is we use our Kirchhoff's law. So now let's implement our Kirchhoff's law over here. But first we need to locate our current flow. Okay, so let's look at this VTH. The VTH current is moving in this direction upwards. Okay, so now let's say we have another current flow in this direction. Okay, let's name this current I1. Okay, now and then we know that from Kirchhoff's law, current entering a node must be equal to what the current leaving a node. Okay, so we know that from here we can notice that this is an open circuit. Okay, the VTH is an open circuit, so there's no current flowing through here. Okay, so it means that this same I1 will flow through the 5 ohm resistor. Okay, yes. Now, so from here we know that let's introduce another current flowing in this direction. Okay, so let's say this current is what, I2. Okay, so we then get to this junction. Okay, this current is entering this junction, this I1 is also entering this junction. Okay, and this one is also leaving. So what will be that? What will be our current flowing in this direction? This what, I2 plus I1. Okay, as simple as that. Current entering must be equal to current leaving. Okay, so this means that the current flow in this direction is what, I1. Okay, this I2. Okay, and then this what, I1. Okay, now so let's move on. So these are what currents. Okay, allocations. Now let's what introduce our what Kirchhoff's. Okay, the K. So we have what, so we have what, K. Okay, we have K, the Kirchhoff's law. Okay, then we try using what, Kirchhoff's law. So you use what, KVL. So let's choose a loop. Okay, so now let's label our what circuit. We have what, B, C. Okay, we have E, we have G. Okay, we have H. Okay, F, D, and what, A. Okay, so now let's take a loop. Okay, let's take a loop. Let's say loop what, let's take loop B, C, D, A, B. Okay, okay, let's say we have what, loop B, C, D, A, B. Okay, so we have what, loop B, C, D, A, B. Okay, okay, so that will give us what, 7 volts. Okay, is what, 7. Okay, because what, 2 ohm, right, 2I2. Okay, and then we have what, the current flowing in the same direction. So we have what, this is what, 3 watts, I2 plus what, I1. Okay, pardon me with this, let me clean this one up. Okay, so we have what, I2. Okay, I1. Okay, then we have what, let's further simplify this. Okay, so we have what, 7 equals what, 2I2. Okay, plus what, 3I2 plus what, 3I1. Okay, so let's further simplify this further. By simplifying further, we have what, 7 equals what, this and this will give us what, 5I2. Okay, then plus what, 3I1. These are what, equation 1, right? So now let's choose another loop. Okay, let's choose another loop. So let's choose loop what, let's choose a bigger loop. Okay, let's choose a bigger loop. So let's choose loop G. Okay, watch carefully. We are choosing loop G, C, D, H, G. Okay, because of this short this open circuit VTH, we are trying to cover the entire circuit. So we are choosing loop G, C, D, H. Okay, D. Okay, so we have what, another loop. Okay, another loop what, G, C. Okay, D, H, G. Okay, and that will give us what, this 10 volts. Okay, 10 equals what, okay, so now this what, are 2 ohm. Okay, 2 ohm by what, I1. So we are choosing this loop. Okay, this loop G, C, D, H, G. Okay, so we have what, a certain, okay, 2 ohm. Okay, we have a certain 2 ohm, 2 ohm with what, I1. Okay, a current I1. Okay, so we have what, I1 and then when you get here, we have what? Another what? 5 ohm with what? I1, okay? So let's see the direction of the current flow. Okay, it's moving the same direction, okay, just as the loop, so it's what? Positive. Okay, so you have what? Plus what? I1, okay, and then you move on to what? Point C. So this is where the current splits, and then you have what? 3 what? I1 and what? I2, okay. So you have the current is flowing in the same direction, okay. Yes, you are moving in this direction, okay. Yes, so you have what? Plus what? 3, okay, I2 plus what? I1, okay. And then when it gets to this point, you have another 2 ohm over here flowing the same direction, okay. So that's what? Positive. So we have what? Plus 2 I1, okay. That's it. Now we simplify it further. This 10 equals what? When we simplify this further, we will get what? 2, okay. So let me expand, okay. Plus what? 5 I1 plus what? This 3 I2 plus what? 3 I1, okay, plus what? 2 I1, okay. So when you simplify this further, you get what? 12 I1, okay, plus what? 3 I2. So this will be our equation what? 2. Now you could notice that we have both what? This equation with I2 and then I1. This also has what? I2 and I1. But we don't know the value for VTH, but that's what we are trying to find, okay. So let's choose another loop where we could find what? VTH, okay. So let's choose another loop. So let's say we have another loop with VTH embedded within it, okay. So let's choose loop EADFE, okay. So let's choose loop what? Let's choose this loop where we will find our what? VTH, okay. We're trying to find a loop where we will have our VTH within it. So let's choose ECDFE, okay. ECDFE, this loop ECDFE. So from here you could notice that we have our what? VTH in there, okay. So we are taking the loop in the same direction as the what? The current flow for the VTH, okay. So we have what? E what? C D F E, okay. E C D F E. So we have what? VTH flowing in the same direction, okay. So we have what? VTH, okay. That's the only voltage source. And then we have what? 5 and what? I1 flowing in the same direction, okay. So we have what? 5 I1, okay. Then we have what? This 3 ohm also moving the same direction, so I2 I1, okay. So plus what? 3 I2 plus I1, okay. And then we have what? Our 2 ohm with what? 2 I1, okay. So plus 2 I1, okay. So when we simplify this further, we get our VTH to be equal to what? 10 I1, okay, plus what? 3 I2. So this will be our equation 3. Now, so from here we could notice that equation 1 and 2 are similar, so you can find their I2 and what? I1, okay. So let's solve equation 1 and 2 simultaneously, okay. So we have what? 10 equals what? 12 I1 plus what? 3 I2. That's our equation 2. And then we have what? 7 equals what? 5 and what? 3, okay. So we have what? 5 I2 and what? 3 I1. So let's rearrange it in that order, okay, so that they will match, okay. So let's bring our 3 I1 over here. 3 I1 plus what? 5 what? I2. So that's our equation 1. So when you solve this simultaneously, we have I to be what? Let's solve this simultaneously. I will be what? 0.569, okay, amps, and then what? I2 will give us what? 1.059, okay, amps. You can solve this using your calculator, okay. Let's punch it on your calculator, and then you'll get your answer. Okay, so let me write this well. Okay, so you have what? 0.59. Now, so since we know I1 and I2, we can most definitely find out VTH from here. Okay, can find out VTH from here. Okay, so we have what? Now you have VTH. Okay, should be equal to what? 10. What? I1 is what? 0.569. Okay, and then plus what? 3. I2 is what? 1.059. Okay, so we have VTH to be equal to what? So when you do this calculation, you end up with what? 8.867 volts. So these are what? VTH. So these are VTH value. Now let's find what RTH. Okay, so from here we can just find our RTH. Okay, so we are done with what? Remove, insert, and then using Kirchhoff. So now we are moving on to what? RTH. Okay, so from now we've solved this over and over again, but let's just apply that over here. So let's use our R. Okay, so we are using what? RTH. So now let's see, when using RTH, most definitely you get rid of what? The voltage sources. Okay, so you have a certain circuit like this with no voltage sources. Okay, like that, like that. Okay, then we have what? Our 5 ohm. Okay, this is where our R will be. Okay, these are RTH. Okay, RTH, and then we have what? A certain 2 ohm over here. Okay, and then we have what? 2 ohm over here. Okay, with no voltage source. Okay, so we have what? 2 ohm, 5 ohm, 2 ohm. Okay, 3 ohm, and then what? 2 ohm. So now to simplify this is very simple. We know that 2 and 3 are in what? Parallel. Okay, 2 and 3 are in parallel. Okay, but first 5 and 2 are what? In series, because from here you can notice that I1 and I1 pass through what? 5 and what? 2. So notice that whenever the same current pass through 2 resistors, okay, they are in what? Series. Okay, so 5 and 2 are in what? Series. Okay, but 2 and 3 are in what? Parallel. So we have what? 2 in parallel with what? 3. Okay, plus 5, which is in parallel with what? Which is in series with what? 2. Okay, and then the whole of this, okay, the whole of this will reduce and then be in series with and be in parallel with the 2 ohm. Okay, so 2 and 3 are in parallel, 5 and 2 are in series because the same current will pass through them. And then after finding that the whole of this, okay, let me just write it this way, the whole of this portion of the what? Circuit will be in parallel with what? Sorry, will be in series with what? It will be in what? In parallel with what? The 2 ohm. Okay, so the 2, 3 which are in parallel, and then the 5 ohm and then 2 ohm which are in series will all be in what? Parallel with what? This 2 ohm. Okay, be in parallel with this 2 ohm. So we have this, right? So when you solve for this, you end up with what? 8.2. Okay, so that will be in parallel with what? The 2 ohm. So this means that, let me just simplify this further. So this is what I mean by 8.2. Okay, so this is what I mean. So we will have what? Have 2 by what? 3. Okay, divided by what? 2 plus what? 3 plus what? 5 plus what? 2. Okay, the whole of this will be in what? Parallel with the 2 ohm. So this, the whole of this, when you do the calculation, this is what? 6. Okay, we have what? 6 on what? 5. Okay, plus what? 7. Okay, and then be in what? In what? Parallel with this. So we have what? 8.2 to be in parallel with this, and then when we solve for this 8.2, okay, times what 2 divided by what 8.2 plus what 2, you end up getting what our final RTH. Okay, note that there is what RTH. Okay, RTH. So we find out RTH to be equal to something close to 1.608. okay, 1.608 ohm. Okay, so when you punch this on a calculator, you end up with what 1.608 ohms. Now this is where the magic comes in. Okay, so we know what this formula. Okay, so this, when we implement this formula, okay, the IN equals VTH. Okay, that's where we come back to what our Norton's theory. Okay, so now let's move on. So you know that Ohm's law is V equals what IR, but we are dealing with what Norton's theory, so we have IN equals what VTH all of what RTH. So you know VTH. Okay, VTH is what 8.867, so we have what 8.867 divided by what RTH, which is 1.608. So when you do this calculation, you end up having your IN, okay, to be around 5, okay, 5.514 amps. Okay, this will be your what IN. Okay, so now this is where you implement the next step. Okay, that's the final step. That's where you bring your what I. Okay, so this was the Norton's formula. Okay, so you have what RN plus what your RL. Okay, and then multiply that by what your IN. Okay, and then we know what RTH must be equal to what RN. Okay, so that's 1.608. Okay, so we have 1.608 divided by what 1.608. okay, plus what RL, which was what 2 ohm. Okay, RL was what 2 ohm. Okay, so we have what 2, and then multiply by what IN, that's 5.514. 5.514. Okay, so we have our I, the current passing through the 2 ohm, to be around 2 amperes. Okay, to be approximately around 2 amperes. When you do the calculation, you might get something like 2 point something, but let's say it's what 2 amperes. Okay, so this brings us to the end of this video. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video, and then I will see you in the next video. Bye bye.